Hi there. Welcome back to the series of video lectures from Introduction to Statistics, the Think and Do book. In this chapter, we discuss various ways that the results, statistical results, can be distorted or biases can be introduced, either intentionally or unintentionally. And it's worth pointing out that books have been written on the topic, and this is just an introduction. We go into percentages specifically because they're used all the time, and they're trickier than you might first think, and a lot of people don't use them correctly, so it's worth going into that into a decent amount of detail. Okay, so when we talk about introducing biases, we'll start off with this example of a loaded question from a survey. And there's two questions. Do you think the United States should forbid public speeches against democracy? And in that, the results came back 21% said yes. They said the U.S. should forbid public speeches against democracy. So 21% agreed with that statement. And then another way of asking the same question is, do you think the United States should allow public speeches against democracy? And 48% said no. And what the point that's being made here is that if you said yes to this one, you should have said no to this one. So these two numbers should be the same, or about the same. And what you notice is that the question is asked in very different ways. And that's all about language, and language is very powerful. And recognizing that the way you ask a question can influence the way a respondent answers is made very clear in this example. I think in the first case, people don't like the word forbid, so they're less likely to agree with that statement. Another way that bias is introduced is in polling methods. Scientific polls specifically require that the respondents are selected from a random sample, and that is not always the case. And so it's good to be on the lookout for that, because even if an institution claims that the poll is scientific, there are certain small differences you can do to sort of skew the results in one direction or another. For example, by the way you might ask a question. Small samples, gotta be careful for small samples because they can often miss important entire segments of the population. You should also be on the lookout for the difference between population and sample. You know, they might be wanting to make a statement about college students, but they only take a survey of students from a small private college, and so the results should not be generalized to the population of all college students. So you have to be on the lookout for the differences between the population you are intending to target and the sample, which may be a subgroup of that population. Correlation and causality are often confused, and there's a whole chapter on that. Chapter 10, we will get into correlation. But the key is that correlation, if two variables are correlated, it doesn't mean that one causes the other to change. But on the other hand, it doesn't mean that there is no cause and effect relationship. So it's a subtle difference, and we go into much greater detail in Chapter 10, but it's worth recognizing that they are not the same thing. Oftentimes you will hear results from clinical trials or surveys, and the trials are sponsored by a given group. And when a trial is sponsored by somebody, it means that it is paid for by that organization. And so you should always be on the lookout for who is paying for the trial, because that can, if not directly, indirectly influence the outcome. And then finally we get to percentages and proportions, and that is, that's what you hear every day, percentages and proportions. And the problem is that these are often used incorrectly, and people think percentages are rather simple, but they're actually more complicated than you think. And so we're going to spend a couple pages on that. So we're going to look at the basics of percentages first. Basically, a percentage is a fraction of 100, and so 82% is just 82 out of 100. And if you represent, so this is a percentage, that's actually a proportion, and you can write the proportion in decimal form like that. And it is possible to get greater than 100%. For example, 134 out of 100 is 1.34. So percentages is just a proportion out of 100. If you want to convert a percentage to a proportion, say 20%, you write that as a fraction of 100, and you can reduce it if you want to make a simpler ratio, or convert it to a decimal. All right. And 4.7%, for example, is just 4.7 over 100, which is 0.047. If you want to convert a proportion to a percent, the best thing to do is just use your calculator. If you take 21 out of 40, if that's your proportion, put that into your calculator, you get 0.525, and then to convert that to a percentage, you multiply it by 100, which is essentially taking that decimal and moving it over 2 places. So you get 52.5%. And sometimes you might have to round. 2/3, when you do that in your calculator, is actually 0.6 repeating. So you might have to round it, and that would become 66.7%. And a percentage of a value basically means you take, for example, 15% of 242, you convert that percentage to a decimal and multiply it by the original value. A percent change, and this is where the biggest errors pop up. If a number changes by a given percentage, for example, if 235 is increased, and that's very important, by 20%, then what you do is you take the 235, the original amount, and you add 20% of that original amount, and you get 282. If it is decreased by 20%, then you take the original amount and you subtract 20% of the original amount, and you get 188. And a lot of people confuse percentages of a value with percent changes, and you'll notice they're very different. So we'll go into the your turn problems. If there are 2,200 students at the college and 1,243 of them are female, what proportion of females are in the college? Well, that's just 1,243 out of 2,200. Plug that into your calculator, you get 0.565. So a proportion is a number representing a fraction or a ratio. A percentage is essentially the proportion in decimal form multiplied by 100. So if you take the 0.565 and multiply it by 100, it moves the decimal place over 2, and you get 56.5%. For B, what is 6% of 80? You convert the 6% to 0.06, multiply it by 80, and you get 4.8. What is 250% of 80? 250% is 250 over 100, which is 2.5 times 80, and you get 200. But now when we start talking about percent changes, some things occur that are maybe counterintuitive. For example, if you start with $100, and in the first year it decreases by 20%, and then the following year there's a 20% increase, what happens to your original 100? Well, in the first year we go down by 20%, so it's 100 minus 20% of 100, and you get 80. And then year 2 you start with your 80, and you go up 20% of the 80, and that brings you to 96. So you actually don't get back to your 100. Right? That's because percent changes are with respect to the original amount. And when you're looking about the percent difference between two different values, it depends which one you use as the basis, as the original value. So for example, we have US Air, and they have a flight for 372, and Continental has a flight that costs $496. If you want to talk about that difference in price in terms of a percentage, it depends which one you're using as the original value. And so the trick to playing this game is you first look at the actual difference. And the actual difference is 496 minus 372. Right, so you want to get the difference as a positive number. So you take the bigger one minus the smaller one. So the difference is actually 124. So with respect to U.S. air, that is 124 over 372. So with respect to U.S. air, that's a 33% change. With respect to continental, you take that same difference, only you're dividing by 496. So with respect to continental, the difference is 25%. Right, so look, the difference, when expressed as a percentage, it depends which one you're referring to as the original value. So when you look at the respect to the U.S. air flight, the difference is 33. With respect to the continental flight, the difference is 25%. So basically what that means is the continental flight is 33% more than the U.S. air, because the implied original value is the continental flight. No, sorry. I had that backwards. The continental flight costs 33% more than the U.S. air. So basically you're saying if you take the U.S. air price and increase it by 33%, you get the continental flight. All right? So the base value is the U.S. air. And the U.S. air flight, which is 372, it's actually 25% less than continental, because the base price is the continental value. So you take the continental value, the original value for continental, and drop it by 25%, and you wind up at the U.S. air. And it's fairly tricky, because look, it's the same difference, but it's a matter of which one you're using as the original value. So you got to keep an eye on that, because a lot of people confuse that. And what gets even more confusing is when you look at percentages of percentages. All right? And this is an actual quote, and it comes from this information. We start with a smoker's risk of death. And we will say, all right, the smoker's risk of death is 60% by heart attack. Death by heart attack is 60%. A non-smoker's risk of death by heart attack is 20%. So clearly not smoking is advantageous with regards to dying by heart attack. And the actual quote was that quitting smoking reduces your risk of heart attack by 300%. And you can sort of see where they got that, because if you look at the 60 and the 20, well, 60 is 3 times 20, so they're saying, 300. There's a 300% in there somewhere. But the truth is, it doesn't reduce your risk by 300%, because, listen, whatever your risk is, if you reduce it by 100%, your risk is down to 0. So you're not going to reduce it by 300%. Better, but still wrong, is if you said, all right, smoking increases your risk of heart attack by 300%. That's still wrong, but I can see where that would come from, because, 60 is 3 times 20. Right? But it didn't really go up by 300%. Right? It went up threefold, but not by 300%, and we'll see that in a second. Correct, you can certainly say that smoking triples your risk of heart attack. And that's a strong statement, and it's actually true, right? If you don't smoke, it's 20, and if you do smoke, it's 60. It triples, goes up threefold. Another correct version would be to say that smoking increases your risk of heart attack by 200%. Because if you start at 20, right, if you go by 20 and you go up to 60, you went up by 40 percentage points, which is actually 40 is actually 200% of 20, right? The difference is 40, which is 200% of 20, so your risk went up by 200%, right? So it's not 300%. It went up 3 times, which is only 200%. You could also look at it by going the other direction. Quitting smoking reduces your risk of heart attack by 66.7%. And that's basically saying, all right, well, the difference is 40. And if you start out with a risk of heart attack at 60, and this is actually 0.667 or 66.7%. Right, so that difference, the change, is 66.7% of the original amount. So it reduces your risk of heart attack by 66.7%. So if you really want to make your case against smoking, you'd probably want to use one of these two because they make it sound bigger. But they are actually the same. If you want to make it sound a little smaller, you might use the original risk of heart attack for a smoker, and the change looks a little smaller. It represents the same change, though. And then you can also say, and this is just as valid, smoking increases your risk of heart attack by 40 percentage points. And that's critical, that points there, because it basically says the change is in percentage points, right? Because you go from 20% to 60%, that's 40 percentage points. So if you wanted to make the difference sound even smaller, you'd go with this version, right? So it's the same difference written in 4 different correct ways. Some sound bigger than others, so it's worth knowing the difference if you're going to make an argument for or against smoking in this case. And so here's a your turn, and there's a lot of stuff going on here. You start at a given bank. The interest you earn is 1.5%. Right, so if you put your money in a savings account, you get 1.5% interest. If you take out a loan, the interest you pay is 4.5%. So clearly, the interest you pay is greater than the interest you earn. And so basically we want to categorize these statements as true or false. So in the first statement, the interest you pay is 3 times what you earn. And that is true because 4.5 is 3 times 1.5. So that's a true statement. The interest you pay is 200% more than you earn. And that is true because the difference is 3. The difference is 3 percentage points, right? From 1.5 to 4.5, the difference is 3 percentage points, which is actually twice or 200% the rate that you earn. So the difference is 3, and that's 200% of what you earn. The interest you pay is 300% more than you earn. That's false. It's a popular false statement because your interest rate goes up by 3 times, but the difference is only 200%, right? So the multiplier and the percent change there's always one difference in there, right? If it goes up by twice as much, then it's actually 100% increase. If it goes up 2 times, if it goes up 2 times, you have a 100% increase. If it goes up 3 times, you have a 200% increase. You could also put it like this. You pay 3 percentage points more than you earn? Sure. And it's true because of the percentage points, right? Your interest rate went up by 3 percentage points. So that's true. And by the way, this demonstrates how many different ways there are to make a true statement, because all of these are true except for this one. The interest you earn is 33.3% of what you pay. Well, that's true because if you look at what you earn, it's 1.5. And expressed in terms of what you pay, that is actually 1/3 of what you pay, or 33.3% of what you pay. And by the way, you got to look at that. Is the key word here is of. The interest you earn is 33.3% of what you pay. Whereas, well, let's do the next one. So we go to this one. The interest you earn is 66.7% less than what you pay, right? And here we're looking at a change, a percent change, and the difference is 3, and that's actually, if you look at 3 over 4.5, that is actually 2/3, all right? And so 2/3 represented as a percentage is 66.7%. So the interest you earn is 66.7% less. And notice the difference here is of, where it's 33.3% of the value you pay. And here it's 66.7% less than. right? So there's a 66.7% change, right? And listen, this is not trivial. And people think, oh, I understand percentages, but it's often much more subtle than you think. So always be on the lookout for percent changes, and especially if you're looking at percent changes where the original values are percentages, you have percentages of percentages. That gets extra tricky. Okay, and something even trickier is called Simpsons Paradox, and this happens whenever you take proportions or averages across categories. And sometimes you can come up with contradictions to the overall averages or proportions. And here's sort of a classic example. You have two airlines, National Air and Regional Air. And you look at the proportion of on-time arrivals, right? National Air going into Seattle, they have a 90% on-time arrival, and into San Diego, 96% on-time arrival. And if you look at Regional Air, their percent of on-time arrivals into Seattle is 88%. Their on-time arrivals to San Diego is 94%. So if you look at these two, right? So if you're flying into Seattle, National Air is better, right? 90% is better than 88%. If you're flying into San Diego, National Air is again better. 96 is a better on-time arrival rate than 94%. But if you look at the combined proportions for the two cities combined, well, for Regional Air, we have 360 plus 48, so we have 408 on time out of 400 plus 50, 450 total flights. So the on-time arrival combined for National Air is 90.6. And if you play the same game for Regional Air, right, we have 44 on time and 376 on time. When you add those, you get 420 out of, again, 450 flights. All right, so if you notice, Regional Air, when you combine them, has a higher on-time arrival percentage. So look, the paradox here is that in Seattle, National is better than Regional. In San Diego, National is better than Regional. But when you combine them, Regional is better than National. And that's why it's called a paradox, is everything got switched around, right? And the key to this is that in this last category, this last column, you're averaging, you're combining categorical data. And really, the reason that Regional won out in the combined category is because they just had a lot more flights that go to San Diego, right? And San Diego has a higher on-time arrival. So because they have more flights into San Diego, it appears as though they have a higher on-time arrival percentage, but it actually isn't true when you look at it city by city. So that's what's known as Simpsons Paradox. We do a couple of these throughout the chapter, this and the next chapter. And it's worth keeping your eye open for, because it can happen and you haven't really even done anything that is immediately obviously wrong. But the thing to be on the lookout for is combining statistics, averages, or proportions across categorical data. Because when you do that, your conclusions actually can contradict each other or flip. Okay, so that's Simpsons Paradox. We'll do a few more of those as we move through the chapters. But the trick is, percentages are worth paying attention to. They are not as immediately obvious as you might think, and especially when you're looking at percentages of percentages. That's when things get really tricky, and you just have to be very careful about what is the original value that you're using as the baseline. Okay, so that is, fooling around with data to come up with, differing results. And sometimes it's done intentionally, sometimes it's done accidentally, sometimes it's actually wrong, and other times it's just presented in such a way that is persuasive. And sometimes it's unethical, sometimes it's accidental. but it's always worth paying attention to. Okay, so that does it for this chapter, and I'll see you. Actually, this ends chapter 1, so we'll do the summary worksheet, and I'll see you in chapter 2.